Hi, so previously we left off talking about the dryness fraction equations, where to revise, it comes in a form of with the dryness fraction x, where x is between 0 and 1. Okay, 0 being totally wet, and it is along the F line, and 1 being totally dry, which is along the G line. Okay, so the equation is if it is wet steam anywhere within under the hill, your enthalpy will have this formula. Okay, you'll be able to obtain the enthalpy at that point based on dryness fraction and both ends, F and G values. H, G minus HF. Alright, and internal energy is also the same, UG minus UF. Okay, and specific volume is, because we assume that VF is close to 0, then your equation specific volume is literally X times VG. Okay, so now we talk about, give an example on how this will work. So example 5-2, page 72. What you have is that the pressure is 40 bar. Okay, so 40 bar is this value on the PV curve, and it is this isobaric line along the TV curve. Okay, so dryness fraction is 0.85. Okay, naturally it's closer to the G line because it is closer to 1, right? So closer to the G line, so we plot it here, similar to on both diagrams. So X is 0.85. So this particular table is actually extracted from the steam tables. If you go to 40 bar on page 5, okay, page 5, this is the first row. First row is 40 bar. Then you have your UF, UG, HF, HFG, and HG over here. So the first row. So the first question, the first part is you need to find the specific volume with X, VG. X is 0.85. Okay, VG is simply 0.04977. Okay, 0.04977. So the answer is 0.0423 meter cube per kilogram. Okay, so this V is exactly this location here. This value is 0.0423. Alright, and this location here along the G point, right? This point is exactly 0.04977. Okay, same here. This is 0.04977. Okay, and then next you're supposed to find H. HF plus X, HFG. So the HF will be 1087 plus 0.85 times 1714. Okay? Two five four 3.9 kilojoules per kilogram. And lastly, specific internal energy is UF plus X, UG minus UF. Okay, or UFG. Okay, if you look at this page A A4 will be the last row, A5 will be the first row. 1082 plus 0.85 2602 minus 1082. Okay. Two, 374 kilojoule per kilogram. Okay, so that is for example 5-2. If we go to example 5-3, is saying that you are given the specific enthalpy, but not the dryness fraction. Okay, but at least the pressure is given at 9 bar. So 9 bar, right, the values are also extracted from the steam tables. Okay, you have your temperature, V, U, and H. But you're given the H, right? So what it means is that H is 2660, and this is equals to HF plus X HFG. Okay, at 9 bars, your HF is 743, X you don't know, HFG is 2031. Okay, so basically you need to do some mathematical calculation to find that X is 2660 minus 743 divided by 2031. $0.9439. Okay. Well, one way to check whether your answer is correct, the first cut, okay, at least your number cannot be more than 1. It can also not be less than 0. Okay, X must always be between 0 and 1. There's one simple way to check it. Okay. So we continue from here, and just to let you see more about the steam tables. Okay, so let's say we look at the superheated steam. Okay, superheated steam, you see that you have values that goes 5 bars. Okay, so at 5 bar, this is the whole value of cluster of values for each different temperature according to the row, top row. Okay, 200 degrees, this is the cluster of values at 5 bar. 250 degrees, this is the cluster of value at 5 bar. Correct? And the top number is volume, followed by internal energy, followed by enthalpy, followed by entropy. Okay, it's the same for both steam tables. But now the question is this: what if I want to get a value, right, that is somewhere in between? For example, I want 5 bar, but I want 270 degrees Celsius. There is no value here. So what do you need to do is to interpolate for the results. Okay, to approximate it to approximate it simply, to interpolate. So I'm just going to give you an example first. For example, so since we're at 5 bar, right, I'll just say that the pressure is at 5 bars. And the temperature I'm looking at is 265 degrees Celsius. What is the enthalpy? Okay, that is the question. Okay, with this question, right, we are actually approaching the next topic, okay, on page 73, on interpolation along the steam tables. Okay, because very often the values are in the middle, they are not the ones given here. So you need to interpolate for the results in between. Okay, and the formula is given here. Okay, it's given here. and it will also be given in the formula tables during your tests and examinations. Okay, so you don't have to actually memorize. Okay, so how should we look at it? Maybe I just create a next video on this. We are approaching the 10th minute.